Hello and welcome back to the channel. It's been a while since I've posted something and I wanted to give you a quick update of what's happening in the shop. I've been really busy working on the 5-axis machine. It has come a long way, but we've hit some potholes, if you like, throughout the past few weeks and months. One of the back-off drives decided to kick the bucket early for no apparent reason. So I'm waiting for that to be repaired and sent back. And we've been having some also some electrical issues with the CPC drives, but we are working on it. From a mechanical point of view, the machine has come a long way. But in this video, as you can see, I've got a new machine. I've picked up this second-hand Boxford lathe just last week, and it's in a very good condition, and I want to work on it a little bit and sort of bring it up to date. And I'll tell you more about this machine a bit further down the video. On this side, as you can see, I've got a new setup. This is manufactured by my friends at Bot. It's a German and British company. They make these fantastic workshop cabinetry, which is really high quality, robust, so do check them out. And let's talk about the lathe first. So this is a 2-axis lathe. The X and the Z axis are driven by a ball screw, and it's on linear guideways, which is quite good. Then you know that the accuracy is relatively consistent. It's only a rolled ball screw. It's not a super accurate machine in any sort and way, but it's got a nice small turret, and I always needed a lathe in the shop, and it's something that I've always missed. I wanted to buy a manual lathe, but then I thought, well, you know what, let's go with something which is CNC, and then I can convert it into a more modern control. Even though this machine is relatively old, I think it's about 10 to 12 or maybe 15 years old. There's no mention of the year of manufacture on the plaque on the side, but by the design and also seeing similar machines that are out there, I think it's around 12, 13 years old. But it's in a very good shape. It came out of a college, and you can tell that it's hardly been used. The control itself works, but it doesn't come with the software. And I've contacted Boxford, and they wanted some ridiculous money, and I thought, well, you know what, we can do a bit better than that. Before I move on, let me give you a quick tour of the machine and how it works. Alright, this machine is actually using a controller which is in the controller cabinet, and it doesn't really need a software to run the motors. My suspicion is, and my guess is that the controller is actually just using the computer as a DNC to drop feed the positions or the part of the program, and then it's doing all of the processing inside. But it's a bit hard to tell, and I'm going to get rid of the whole thing anyway, so it doesn't really matter. But using this panel, you can actually control all of these axes and everything else. So if I hit that button, it should come to life, and you can jog the different axes with these buttons. So that's your X, and you can do rapid movement as well, or the other way around. And your Z axis. The turret turns as well. It's just one direction turret. It can't go back. There are other videos of how these turrets work. You can find them on YouTube. And then the spindle obviously turns as well using this button. And it just indexes, each time you press the button, it just increases the speed of the spindle. And you can go clockwise or counterclockwise. Then the coolant pump works as well. And the door on the side, you've got an interlock mechanism. So when actually it's running, for example, like that, if you open it up, then instantly everything stops, which is quite good from a safety point of view. There's also a pneumatic cylinder to sort of remove the weight of this this door, so it's sort of made it balanced. So wherever I let it go, it kind of stops, which means you just need a regulator for your air that goes into that pneumatic cylinder, and then you've got this button that catches it. So when you go all the way up, it can't come down unless you pull that out and then press down. So it's all self-contained. There is a tail stock as well, which you can bolt onto on that lower rail, and all your swarf goes through a hole down there, and then coolant gets recirculated and comes back up. Let me show you the mechanism on the side as well. Okay, on this side you can see the actual spindle assembly, and we've got a belt system which has got a pulley on this side, and these are the optos that I mentioned. So there's actually two of them, and this disc which has been laser cut with some grooves in it, or some marks, so when you are actually turning this, it can read the speed. Then you've got the Z-axis stepper motor, and the thing I liked about it, and sort of it caught my attention, was that it is actually a very nice built machine. You can see they've used, I call these power locks, so power locks and good timing pulleys, and the whole construction is very well built. Everything that is on the sort of structure of the machine is actually cast iron. So you've got things like the main bed, it's cast iron, and then you've got the spindle assembly, which is another cast iron part. So it means that you've got some rigidity and vibration dampening already built in. And the actual construction of the sheet metal is very well done as well. And on the other side, you've got the main motor, which is down there, and it's using this pulley system to connect it to the spindle. I can turn the spindle on. You can see how it works. And yeah, it's quite good. It's got even a small box when you put this lid on to catch any dripping coolant, and it sort of guides it back down. So it's a very nicely and well-built machine. Okay, as you saw, it's in a pretty good shape, and everything is functional, obviously apart from the controller. So my plans were to actually change this panel, just remove this completely, and put a new piece of maybe stainless steel or something, and then put a touchscreen monitor with a few buttons and maybe a hand wheel down here, all of it contained within this panel, plus maybe a emergency stop button and maybe a cycle start stop button, something like that, and keep the whole thing very minimalistic and contained within this area. I first wanted to convert it to Mach 3, but then I thought, well, I can do better than that. My control has come a long way since I've showed you that little snippet a few months back. The control has got a very fantastic looking tool management system, which is a combination of all of the good features that I've seen from other controls throughout the years, plus a lot of sort of workflow management and various G-code editing, and the machine vision in sort of built-in probing cycles, and I'm working closely with Renishaw to include the set and inspect software into it. So it has come a long way, and that's one of the main things that I've been working on over the past few months. So I thought, well, that control already has turning capability, because my 5-axis machine is a turn mill machine. So I thought maybe actually it's better to use those features and tweak it a little bit more, and use my own control on this machine and develop the turning functionalities even further, specifically for a machine with a turret. But then I need to modernize a few things. For example, I need to change the stepper motor drives, because these stepper motors are using pulse direction, and I don't want to use that and put a sort of a middle board. I just want to use EtherCAT throughout the whole thing. So I've purchased some new motors for it and some drives. I could have just gone with the drives, but I thought, well, while we're at it, let's just change the motors as well. So I'm changing the motors to some encoder type motors, or closed loop steppers, which would be faster and more accurate. But then I don't know if I want to spend more money on it and change the whole motor situation as well, the main spindle motor. It's now using a three-phase motor, and it's got a VFD inverter as well, which is using a analog input to control the speed, but it's also got an opto system which can sort of send the speed feedback back to the control, so that the control can keep the speed very consistent and accurate. So if I want to do that, then I need to buy some EtherCAT cards, which can sort of drive the cost a little bit up, and I don't really want to spend a lot of money on it. So I was thinking maybe actually completely change the whole motor system and put a new servo inside, and then use like a timing belt as opposed to the current pulley and belt system that it's got. So that's something that I want to ask you guys to give me some suggestions if you think it's worth spending that money. There are some good Chinese EtherCAT servos, but it's going to cost me around maybe £350, which is going to be like $450 or something. So I'm not sure if the machine is worth spending that much on top of all the other things that I'll be spending on. So you're talking about something around $1,000 on top of the actual machine. Yeah, so tell me in the comments if you think it's worth doing that, or just buy some EtherCAT cards and then use the current and existing servo, the current and existing motor and the VFD drives instead of the servo. So that's something that I need you guys to tell me. Apart from that, I just want to tell you that keep watching the videos, and please put your questions and comments down in the comment section, and it encourages me a lot to sort of make more videos for you guys. And I am planning to bring more videos out soon, especially around the main machine, which is just over there on the side of the camera. And as I said, it has come a long way. But I'm just sort of trying to get rid of all of these electrical issues that we've had over the past few weeks and months. But yeah, thanks for watching the video, and make sure to hit that subscribe button and leave your questions and comments down below. I'll see you in the next one very soon.